So thank you everybody for coming. Good morning, and welcome to the second day of reInvent. And over the next 60 minutes, we're going to be going through this session on AWS IoT and Greengrass for multi-access edge compute. And this is a session in collaborations with Nokia, and I have my colleague here, Marco Hokkanen. I'll be introducing him in a bit. I am Robin Harwani. I'm a partner solution lead for Amazon Web Services focused on the strategic telecommunications partners. And Marco, do you want to introduce yourself?
Yep. My name is Marco Hokkanen from Nokia. I'm an end-to-end customer solution architect, and I have been focusing for the edge computing for the last 2 years from the solution, business development, and use cases point of view.
Thank you, Marco. So for those of you who are familiar with Nokia, I think this would be a quick refresher. But Nokia has been in the industry for communications for over 150 years, and they have a very diverse portfolio. They lead a lot of segments within their portfolio as well. They have everything from IoT connectivity applications, as well as mobile networks, ultra broadband connectivity that they offer to their customers, IP interconnectivity, cloud solutions, as well as digital health solutions that they offer for their customers. And as we get into the learning part of this session, there is 5 things that we want you all to take away from this session. One, what and why of edge computing. We want to make sure everybody understands what we see, what we have learned from an edge computing perspective, and also share with you how we have seen the problem definition change over a period of time. Connectivity plays a critical role in any sort of edge compute solution. We'll be walking through the private LTE and multi-access edge compute solution from Nokia, and how we have integrated that solution with AWS Greengrass and Sumerian, which is our VR application that was launched last night. And finally, we'll leave you with the use cases that we are focusing on, the vertical applications that we are focusing on going forward. And we will be showing a demonstration video of what we have put together for you all. And we also have a physical private LTE network that we have set up in ARIA in the Builders Fair at the Quad. We would really welcome if we can carry on the conversation there. If time permits, we will sit around here at the outside of the room to take some questions and have some collaboration as well. But we have a jam-packed session, so hopefully we get some time at the end for some collaboration. So with that, jumping right in. What and why of edge compute? There's a lot of different definitions that we get from everyone when we talk about, whenever I talk to customers, what is edge compute? Is it computing platform set up at the access side of the network? Is it at the transport network? Or is it closer to the core? Where does it lie? And the answer really is, what is the problem you're trying to solve with edge compute? Is it a latency problem? Is it an economics of backhaul that you're looking at? Or is it something regulatory or privacy issue that you're trying to solve? And each one of them have different architectures, reference architectures that you can set up. But from a common definition, where we want to start today is edge computing is a method of optimizing cloud computing systems by performing data processing at the edge of the network, closer to the source of the data. So that allows you to optimize your resources as you process them. And okay, so why is edge computing important? Most of the machine data never gets to the cloud. So if we take examples like a medical equipment, which is in a hospital due to privacy and regulatory reasons, even though you have all of the data duplicated in the cloud, you need to have local copies of that information within the hospital. Or it is industrial machinery where you are trying to make autonomous decisions, if it's on an autonomous car use case, or some sort of a factory automation or industrial automation use case that you're implementing. You need to have some sort of a computing mechanism at the edge for you to allow to solve that problem. Or it can be some sort of an extreme environment, whether it is a mine, an oil rig, or some sort of a a ship that is in the ocean, that is having intermittent connectivity or no connectivity to the outside world. So all of these issues need some sort of a computing mechanism that allows processing of data closer to the edge of the network. Moving into why this problem is not going away, right? So we've called there's three laws that we call ourselves, the laws of physics, the law of economics, and the law of the land. Law of economics is just the fact that the bandwidth, the cost of bandwidth has not gone down proportionally equally as the cost of compute and storage. So the economics of doing computing at closer to the data makes a lot of sense in cases where you have massive data and the bandwidth cost is going to be exorbitant. Then we have the law of physics. So latency is a big problem in some of the use cases, and having the right solution that allows you to make latency sensitive computing algorithms and implement them at the edge is very, very important. And finally, the law of the land. Like we talked, there is a lot of use cases in healthcare and other industries where regulatory requirements mandate that we have the data closer to the source, and we do not ship, even though it might be duplicated in the cloud, the availability of the data locally is extremely important. So what does AWS offer in terms of edge services? Of course, we're going to talk a lot about Greengrass today. Greengrass is our service that extends our IoT capabilities to the edge of the network, allows processing of information locally closer to the source. Then we have Snowball Edge, which is our 100 terabyte storage device that allows for local storage and compute on the device itself. Then we have Lambda at the edge, implementing Lambda functions at the edge of the network, as well as CloudFront, which is our content distribution network, which allows for low latency, high-speed distribution of content for our customers. And at the center of this whole thing is, again, what service do I use? That's a common question that we get from a lot of our customers, and the answer really is, what is the problem you're trying to solve? But regardless of the problem you're trying to solve, one common denominator that we see is connectivity of the service at the edge and having reliable connection and a platform that allows you to perform edge computing is an important factor. And that's where the role of the partner Nokia becomes extremely important. And I'll hand it over to Marco for defining the problem statement of how private LTE networks for enterprises and operators help them implement these use cases very efficiently. Marco?
Thank you, Robin. Okay. So over here, you can see that when we are adding more automation, efficiency, and digitalization, so this is the preparation for fourth industrial revolution. And over here, for these verticals and use cases has certain requirements. Reliability, so they are expecting more from a reliability point of view for the security and safety. Then there's a business efficiency and agility and capability to rapidly deploy and monetize new services and use cases. In the solution areas, we have flexible and scalable wireless networks for connectivity and capacity, and local data processing for almost real-time services. Over here, we are looking at like the deployments in the network edge, like Robin was mentioning in the AWS Greengrass. Here is why these private LTE networks are coming now. So we have been using, or all of us, we have been using LTE on your smartphones and tablets for a long time, and you know that what kind of performance they can provide. So it's like a much better performance comparing like 3G to LTE. And over here, we are focusing especially for the mobility, reliability, security, and low latency. And key LTE network characteristics are mobility. So we can move IoT sensors or devices up to 200 miles per hour that when the device is moving. On coverage, we can cover with the one LTE cell. When we have an extended cell, it will cover 100 kilometers, so 60 miles. On reliability, we can easily meet 5 nines reliability. On the performance, we are supporting end-to-end quality of service, and over there, we can guarantee key performance indicators with the short latency and throughput. On security, we are supporting this end-to-end military-grade encryption. From the deployment models, these are already done by the carriers with the existing LTE network, so they pretty much provide services for the enterprises, like big carriers already over here in the US. Then for the enterprises, we can build up networks which are based on the LTE technology. Those are citizens broadband radio services, and then it's multifier. And what is the benefit with those technologies that you don't need to own the LTE spectrum to build up LTE networks. Because in the current networks, you need to own the LTE spectrum, which is extremely expensive. So it's like if you own in the US, let's say 10 megahertz spectrum chunk, so it is billions of dollars. And then we are adding also multi-access edge computing. Over there, we will provide this guaranteed ultra-low latency, location-aware applications, and security and privacy via local breakout. Here's the information about these two technologies that I was mentioning, that you can build up LTE networks without owning the spectrum. The first technology that will be launched in the US market, it is called Citizens Broadband Radio Services. It is working on the 3.5 gigahertz, and over there, FCC has allocated 150 megahertz, which is a lot of spectrum. So current carriers, when they are providing LTE services, so they are using maybe 10 to 20 megahertz spectrum over there, and you can see that now we have 150 megahertz on the CBRS, so that's a lot of spectrum for the enterprise use. Then we have a global technology, which is called multifier, and this will be on the 5 gigahertz spectrum, and over there we have like a 500 spectrum available there, so even more than on the CBRS for the enterprise deployment. About the commercial availability, CBRS networks will be available commercially already on the first half 2018, so in a couple of months. Then on the multifier, we are expecting that the first commercial networks will come on the second half 2018. And on the CBRS technology side, so over there, you need to have a permission from FCC, but you don't need to own the spectrum to launch the network. On the multifier, this is based on the unlicensed technology, so it's the same thing like Wi-Fi. You don't need to have a permission when you are launching the network over there. Next one, we are going to talk about that, what is this joint solution between Nokia and AWS over there, which is based on the Nokia is providing end-to-end private LTE network, multi-access edge computing, and then AWS is providing AWS Greengrass. So we will look at this each solution one by one, and then what is overall solution and what are the benefits. But let's look at first what kind of use cases Nokia has already deployed based on our multi-access edge computing solution. All these 8 examples that you can see over here, so we have been doing this on the proof of concept level either with the carrier or enterprise. Augmented reality use case we were doing with the Asian carrier. Car2X is the ongoing program with the German carrier. Campus LTE, we provided this private LTE with our multi-access edge computing on the enterprise. Real-time video over here, so this is edge video orchestration, and this is targeted for the sport venues. So we have been doing this proof of concept in Asia for the Formula 1 car races, and then also in a baseball game in the US. And over here, there's already that kind of services available over the internet, and then when you're comparing what's happening in the race itself, and then you get that information for your smartphone or tablet when you have the application installed over there. So it's 25 seconds delay. With this one, we will get it 1 second delay. So it's almost the same thing what you can see over there. You can see the same thing also in your smartphone. Then we have also this surveillance cameras use case that we have been deployed, the same thing for the object tracking. Live virtual reality, we made that as a cooperation with the Nokia technology team. This is focusing for the end user customers. And the people finder was deployed with the carrier in Saudi Arabia over there when there was this yearly huge event, that they were able to find the people if they were lost. Enablers for the fourth industrial revolution. So we see that there are like two technologies which will enable this. So it is this private LTE networks together with multi-access edge computing. On the right-hand side, you can see on the high-level architecture what is the solution. So first, private LTE means that it is the LTE network where we have this macro or small cells, then we have a transport network, and then we have this evolved packet core, which is the core network. And when we are adding this multi-access edge computing, in practice it means that we are adding data center, and then we are integrating multi-access edge computing platform working over there. And this is end-to-end solution. This solution is fully standardized, so our multi-access edge computing is based on the HMX standard, and Nokia is one of the founding companies for this standard. That happened like 6 years ago, and Nokia was the leading, acting as a chairman for this standardization program the first 5 years. Solution is radio agnostic, so currently we are supporting LTE and Wi-Fi and citizens broadband radio services, and in the near future we are going to add it over there multi-fire, fixed networks, and also 5G. Then we are doing collaboration with other standardization bodies like 3GPP and GSMA, and this will make mobile networks data aware. Over here you can see what is Nokia multi-access edge computing. First we have like this high-level architecture picture. How does it look like that when we are adding multi-access edge computing for the LTE network, and the right-hand side, what are the key technical highlights? So first you can see that this traditional LTE network architecture, that you have this LTE macro or small cells, you have transport network, you have core network, and then you have a connection to internet. And now when we are adding multi-access edge computing, one of the radio transport network aggregation points, we need to analyze that how much there's a traffic. So we are normally supporting 45, 50 LTE small cells or macro cells, and over there, if there's no data center already available, we will install data center, and then we will integrate there a Nokia virtualized multi-access edge computing platform and local breakout. And of course, when we have this data center, in the same data center, we are going to add all the other applications, data analytics, artificial intelligence, machine learning, whatever is needed in the enterprise or carrier network to deploy required use cases. From technical point of view, so this is the virtualized platform. So in practice, we are supporting any x86 hardware. We are testing that one, of course, against our Nokia own airframe data center, then also Dell server, and HP Gen 8 and Gen 9. So multi-access support, so we are supporting this Wi-Fi, LTE, CPRS, and later in multifier, fixed networks, and 5G. This will act as an enabler for this private LTE deployments, and we will provide high performance, enhanced security, privacy, and reliability, because we can do this private networks there, and fully standardized solution.
So, as we look at this solution, we went through different demos, different use cases at the very beginning of this section, and we looked at how would we go about putting the entire thing together. First, we set up the private LTE network, then we went and talked about the multi-access edge compute solution. Now, the third component of the solution is Greengrass, right? With Greengrass implemented on a virtualized MEC platform, MEC stands for multi-access edge compute platform, you have now extended the capability of implementing Lambda functions or integrated on your edge compute solution. Along with the security that you get with AWS IoT, what you also get is a ubiquitous programming model. So the same Lambda function, suppose you wrote up a Lambda function in a Node.js or Python 2.7, you can execute the same Lambda function in the cloud, at the edge of the network, and extend it to the very axis of the network as well as you progress, should you choose to. So that ability to extend the IoT capability from AWS with Greengrass helps to compute and enable programming at the edge. And we will show you in a little bit as to how exactly the traffic flow and the pattern changes, along with a demonstration in terms of a use case. Yuna.
So over here, you can see that what is this end-to-end joint solution with Nokia and AWS. So it is end-to-end private LTE network and Nokia multi-access edge computing with AWS Greengrass. And let's look at first this end-to-end solution architecture. On the left-hand side, you can see that we have this, let's see that. We have these IoT sensors, devices, and smartphones, and still quite often sensors and devices doesn't have any cellular capability, so we need to have some kind of modem or CPE which has this LTE capability, and it will connect these devices then for the LTE network. Then we will provide over here this LTE small cell or macro. Then we have transport network and LTE core. So this is this end-to-end connectivity based on the LTE. And over here, now when we are adding this multi-access edge computing, so we will build up this data center if it's not available in the transport network on the radio. And over there, we will add this virtual multi-access edge computing and local breakout functionalities from Nokia. And this makes possible that then we can route all this traffic for the network edge when needed. Then we'll integrate this AWS Greengrass over here and all the other applications what are needed to deploy required use cases. Like I mentioned already earlier, that all this like data analytics, artificial intelligence, and machine learning, everything will be in the network edge. And now over here, after this LTE core network, we have internet and AWS cloud, and we have these main AWS IoT services. Over here you can see that on the solution side that what is provided by Nokia, Amazon and partners. So Nokia is this connectivity provider, so we will provide LTE radio, transport network, data centers, multi-access edge computing, local breakout and LTE core. Amazon is providing AWS Greengrass core, AWS SDK, which is used to create this big ecosystem there for the IoT sensors, devices and applications, AWS Cloud, AWS IoT Services and Network Intelligence. Partners will provide IoT sensors, IoT devices, LTE modem and CPEs, applications, content and network intelligence.
So I guess to sum it all up, what did we kind of learn in this solution as we go through a specific use case with 4 different solution components as we go through this? First thing that we learned is this entire solution, without a MEC platform, you would be looking at a traffic flow from the IoT sensors over the radio network through the site aggregation point, the mobile network aggregation point, to the core network and all the way to the internet. That's the regular pattern that you would see in absence of a MEC solution. When you introduce the MEC platform, your traffic can now dynamically choose, you can choose and set it up so that you are leveraging your multi-access edge compute solution. What does that allow you to do? You can process data locally, but still you have to implement each application that you have in an indigenous manner on top of the MEC solution. So you really need a platform that allows you to implement thousands of functions in a relatively easy manner. And that's where, with AWS Greengrass, you can leverage these thousands of Lambda functions that you can implement on the edge of the network. And once you implement these functions, you are also leveraging a common programming model that is extended from the cloud all the way to the edge of the network. And the second thing that you are doing is you are also enabling, leveraging the power of the Lambda ecosystem, the developers that are building consistently multiple use cases. And you can leverage them and build new applications on the go. That allows you to speed up your process of building new applications at the edge, and it also allows you to do it in an extremely cost-efficient manner. So going into the vertical applications and use cases and the demonstration. Go ahead, Marco. There you go.
Okay, yes, so let's look at first which verticals we see that will get the most benefit of this our joint ecosystem platform. And over there we have analyzed that it would be this industry IoT over there, like to make these deployments into factories, warehouses, and manufacturing. Then there's a transportation for the airports, railways, harbors. Then we have mining, oil, and gas to do these remote deployments over there. And the fourth one is then logistics. And over here, when we look at this customer segment, so we see that first it would be enterprises, then it's carriers which are providing services for the enterprises, and third one is the carriers. Now we will talk about this demonstration. And as Robin mentioned earlier, that we have actually this physical demonstration then in the builders area. So please come over there that we can have like much more detailed discussion then. So this is our we are demonstrating about the shipping containers, and this is the current situation over there, that those the biggest ships, they have like 20,000 containers, but only 1,000 refrigerated containers has the sensors, which can then track like humidity, temperature over there. But there's like one big problem. This connectivity, it is based on the GSM, and the satellite is backhaul, so it's like a limited capacity over there. And over there, it causes that there will be a delay in accurate information updates with unreliable connectivity, and the end user experience is not the best possible. And now, what we are demonstrating for you, that we have this Nokia private LTE network based on this Citizens Broadband Radio Services technology and multi-access edge computing with AWS Greengrass and Sumerian. This is virtual reality demonstration. And on the left-hand side, you can see that on this high-level architecture, and actually we have this whole system up and running in our booth over there. So we are using this Oculus VR headset to get this VR experience. And this is connected through the Ethernet to CPRS LTE CPE. And this is connected to our CPRS LTE small cells. And over there, then we have a Dell Edge server where we are running all these virtualized applications, our virtualized multi-access edge computing, local breakout, AWS Greengrass, and also Nokia virtualized core network. And then we have a connection through the internet to the AWS cloud and the main AWS IoT services. On these solution components, on this proof of concept, so Nokia is providing this CPRS LTE small cell, our virtual multi-access edge computing platform, local breakout application, and virtualized core network. On Amazon is providing AWS Greengrass Core, AWS Greengrass SDK, AWS Cloud, and AWS IoT services. And over here, we have been using our partners. So Gemtech has provided CPRS LTE CPE, Dell is providing the server, and Oculus VR headset.
So let's go right into it. So what you see here is a ship, and as Marco mentioned, you have 20,000 plus containers in every ship. And just because the number of containers that they can run power to has some limitations. Typically, they have around 1,000 containers that carry sensitive goods that are temperature sensitive or humidity sensitive with some sort of monitoring for temperature and humidity. So for the purpose of this demonstration, you see at the top of this screen 3 bubbles. What do they mean? To the very left of your screen, the bubble that means is, hey, the internet is good, right? Then the one in the middle is internet is intermittent, and the one on the right for you means is it means is we have no internet, meaning we are working in an offline mode and we are on a ship. But we still need to know what is the current temperature of a given container. We still need to know what is the humidity for a given container in real time. And we cannot be, and given the nature of the goods, sometimes it's medical supplies, you cannot really spend a lot of time that you would not have the information should there be a temperature spike. In addition to that, if there is a temperature spike, there is a challenge that the shipping companies threw our way is that, hey, we want to make sure in a total span of say 20 days, if it's on day 2 that a container is has an accident and the goods are impacted in terms of quality, then we want to know on day 2 and not on day 5 so that we can ship the new container right away. So our supply chain is managed and maintained. So those were the kind of challenges that we were looking at. And you will see as I start this, right now we are in good internet connection. The latency to the cloud is around 272 milliseconds, and still good internet connection. We are going forward, and you will start seeing the gray boxes on the containers that are showing temperature and humidity. If I can get the, yeah, thank you. So the gray boxes that are showing the the temperature and humidity of each of the container, and you can see the latency here for the calls that are being made to the cloud for when the internet connectivity is good. Now we're going to switch over to an intermittent internet connectivity mode where you will see the impact on latency would increase. So now you can see here we are at 1100 milliseconds in terms of latency. And as you would start seeing, the gray temperature is still being shown, but all of a sudden the latency will increase here. We are at around 1200 milliseconds, and when you look at the edge, we are at 24 milliseconds, less than 30 milliseconds. So almost a 20x improvement in terms of the performance in terms of round trip and latency when we look at the solution. Now we are in the intermittent mode still. So just remember that we are in the intermittent mode. We are off the harbor, but somewhere in a situation where we can still have some sort of internet connectivity. Now we have switched over to the offline mode. So now we are in the offline mode. You can see the cloud latency is 0, which means we have now no connection to the cloud. However, we can see at the latency to the edge is around less than 30 milliseconds. So that provides your customers the same experience at in a mode where they have full internet connectivity, intermittent connectivity, and no connectivity, working in complete offline mode. This is all implemented using Nokia's private LTE network and with the MEC solution, AWS Greengrass, and at the booth you can see it with the Oculus glasses with virtual reality using the AWS Sumerian service. So you can navigate through that as well. So just to level set here in terms of the solution that we put together allows you to leverage all these 3 modes and work in an offline mode as well. Now once you get connectivity back to the cloud, you can send meaningful information to synchronize your platform on the edge to the cloud as well, which allows you to not just do the real-time actions, triggers, and the compute capability at the edge, but also synchronize your data with the cloud while optimizing your backhaul bandwidth. That's really what the entire solution provides. So, Marco, do you want to? Yeah. One more.
Yeah. So these are the benefits that you get this proof of concept, what we have done. So this low latency comes. So I think you saw already that what was our proof of concept configuration. So the whole private LTE network, data center, multi-access edge computing, AWS Greengrass, everything is inside the chip. So of course we are like really close for the IoT sensors and devices. So there comes this low latency. Cost savings comes there. That of course now that if you are on the ocean, so of course the only way to do like this transport is to use the satellite. But then we can do on that way that we will send only this meaningful aggregated data over the satellite. So we will save like transport cost over there. And of course now when the network is based on the LTE, so you will get the full LTE network performance inside the chip. So it's not only for those IoT sensors and devices, but it's the whole communication what you are doing inside the chip. Now we look at the lessons learned, and let's start first what Nokia is bringing to the table. So of course, like we said, that we are this end-to-end connectivity provider. So we will provide this private LTE, and our solution is multi-access. Currently, we are supporting LTE, Wi-Fi, and this citizens broadband radio service technology. And in the near future, we are going to add it also multi-fire, fixed networks, and 5G. Our multi-access edge computing platform will enable Internet of Things, machine learning, artificial intelligence, and all the required applications in the edge. So then it means that we can easily do like this remote deployments because you have the whole network is over there. Our solution is virtualized platform, and it can be deployed in a part of enterprise or carrier network. And the solution is fully standardized based on this Edge standard, and we will provide this low latency for the applications.
And with Greengrass, to complement, I think we covered this, but one thing that we get is local actions with Lambda functions that you can implement. You can leverage the Lambda functions that are available to you with the ecosystem that we have. You can drive local triggers and have local message brokers that you can set up for your use cases, whether it is a simple use case that does notifications for a public sector customer, or it is a use case that allows you to make video surveillance possible at the edge and leverage machine learning. And then, or it could be something like a VR application that you're implementing on the edge for a low latency use case. All of that can be implemented at the edge using Greengrass. Of course, you get state synchronization of your devices, as well as creating your by creating your device shadows that you have within Greengrass. This will allow you to make sure, as you go from those three bubbles, when you go from the no internet connection or offline mode into the intermittent connectivity or full internet connectivity, you can have meaningful data that is synchronized from your platform on the edge to the AWS cloud. That will allow you to do historical analysis of that data and take meaningful actions over a period of time, and at the edge allow you to take real-time actions, as you saw in the shipping container case. And then if you look at the security certificates that are available for mutual authentication, that will allow you really to look at AWS grade security being implemented on the very edge of the network. So that's very powerful in itself, and that's fully integrated with the solution that we presented over a private LTE network that can be used by an enterprise, or it can be used by a carrier for integrating any sort of use case that they want to implement for low latency. Yep, so this is what we had to present, we share with you. Feel free to stop by at the Builders Fair at ARIA at the Quad to look at the working solution. And thank you so much for taking the time. Really appreciate it.
Thank you.